Greetings, this is m squared, and we're going to solve some trig functions where an interval is not given, where they just ask for all values. So just keep in mind this little chart, that it's a handy dandy little thing to have, because we're going to have some linear equations and some quadratic equations. So we want to keep that in mind. Remember, linear equations are just when you have an x, and quadratic equations are when you'd have an x squared. Although this doesn't have an x squared, it has things in parentheses, so that's a squared kind of thing. So this is still quadratic, which means it will have two solutions. And then this has two squareds, and so we'll talk about that. There's a couple different ways to solve that. So let's get started. So first of all, in linear equations, remember the goal was always to get the variable alone, and we are considering this a variable. The x cannot be by itself. Cosine, you have to take the cosine of something. So this becomes our x. This is what we're trying to get alone, the cosine x. So first I would add 1 to both sides, and I would get the square root of 2 cosine x equals 1, and then to get cosine x alone, I would divide by the square root of 2. Cancels out on that. So I end up with the cosine of x equals 1 over the square root of 2. Now, most of the time we want to simplify radicals so that there's no radicals in the denominator. We do that by rationalizing the denominator. So I'm going to multiply by the number 1, but the number 1 I choose is radical 2 over radical 2, which gets me radical 2 over 2, which is how you'll see it in most little charts like this. So now I'm going to say, well, when is cosine square root of 2 over 2? So I look here, cosine's the square root of 2 over 2 at 45 degrees. We're in radians, so it's pi over 4. And then I also have to know when cosine's positive. Cosine's positive because cosine is x in this quadrant and this quadrant, because when you go right, x is positive. So my reference angle is pi over 4, so I know I need a pi over 4. I'm pi over 4 from the x-axis. So this obviously is just pi over 4, and this would be, if we went 4 pi over 4 and then 8 pi over 4, this would be 7 pi over 4. And some of you might just have that on your chart. If you know your reference angle is pi over 4, then you just look for the one with the 4 on it. So those would be the two answers in 2 pi, but they asked me for all values. So in order to do that, I use n as the number of times I'm going around, because I could go around this way, I could go around the other way, we could go around forever and still get these answers. So how we write that is we say pi over 4 plus 2 pi n, and n means the number of times I'm going around. So that works for this answer, for the pi over 4. But I also need all the answers for this. So then I say, or 7 pi over 4 plus 2 pi n. And those are my answers. So it's a little bit different when you're not given an interval. Let's try this one. It's quadratic, so we have to be careful with that. Our goal is when we have a quadratic equation and we have just the quadratic term and the constant, there's no linear term or an x term, the best way to do that is always to use square roots. So to get this alone and then square root both sides. So we're going to add 3 to both sides. We're going to get tangent squared x equals 3. To get rid of a squared, remember, to get rid of subtraction, we add. To get rid of multiplication, we divide. The opposite of square is square root. So we're going to square root both sides. And what many people forget when you square root both sides is that the other side, you have to say plus or minus. If I said what squared equals 25, usually initially everybody says 5, but there is another answer, negative 5 squared is also 25. So that's why we have to do this plus or minus, because there's those two possibilities. So when is tangent square root of 3 is what we need to know. Well, tangent is square root of 3 at 60 degrees. Oh, but we're in radians, so we have to use pi over 3. So we know that it's at pi over 3. And since it's plus or minus, that means in all 4 quadrants. Now, I didn't draw this really pretty, but it should be straight across. And that helps us when we go to do our little formulas, because these two, well, those are my reference angles. Let me put in the other. So that's 3 pi over 3 pi over 3 is here, which is pi. So that's 2 pi over 3. This is 4 pi over 3. and that's 5 pi over 3. So because these are 180 apart, what I can do is I can say pi over 3 plus pi, which is 180, n, because that gets me this one. So if n was 1, I would be here. If n was 2, I would be back here. So instead of doing 4 different ones, and you could do 4 different ones, you could say pi over 3 plus 2 pi n, and then 2 pi over 3 plus 2 pi n. But it's a little easier to just have 2. So if you can see that they're 90 apart or 180 apart, it's better to do it that way. So then we'll just go to this one, and we'll say, or the answers are 2 pi over 3 plus pi n. And then that takes care of those two. Okay, let's do it in degrees, which is what I've been trying to do, unfortunately. Okay, so we're going to solve these equations for all values, no interval is given, and we're going to do it in degrees this time. So this is quadratic, but remember, factored forms of equations are our friends when 0 is alone. We don't want to multiply those through, because remember when we did quadratic equations, we factored and then we set each factor equal to 0. So that's what we're going to do here too. We're going to set this factor equal to 0 and this factor equal to 0. And then we're going to solve. This one's ready. When does sine of x equal 0? Well, sine is y, so up and down it changes, left and right it doesn't. Right here and right here. So at 0 and 180, I know are my answers here. If I add 1 over here, and then I divide by 2, I get cosine x equals 1/2. Well, when is cosine 1/2? Cosine's 1/2 at 60 degrees. So for cosine, it's positive in these two quadrants because it's x, and x is always positive when you go to the right. So I have little reference angles of 60, which means this answer is 60, and this is 360 minus 60, which is 300. So over here you notice that these are 180 apart. So it's really just, you could say 0 plus 180n if we were doing it the other way, but you really don't need that 0. So the answer here is just 180n. And as we go around 1 time, it's here, and then 2 times, 3 times. If you went around 0 times, it'd be there. So that's our answer for this first factor. And then over here, we have 60, and then this is not consistently like 180 or 90 apart. So we have to go back and do the 360n. Or we have 300 plus 360n. So these are the answers for that equation. And now onto this one. There's a couple different ways you could do this. One of the ways is to use your reciprocal identities, because sine squared plus cosine squared equals 1. If you remember, you couldn't solve an equation with an x and a y in it. So this is kind of like our y and x, but we could substitute. Remember, if sine squared, this is my little abbreviation, if sine squared plus cosine squared equals 1, then cosine squared, if I minus sine squared from both sides and it canceled out, cosine squared would equal 1 minus sine squared. So that's one of the substitutions you can use. And I'll show you a different way to do it in a minute. So I'm going to do that. I'm going to say sine squared x equals 1 minus sine squared. So I make that substitution because you always have to have the same function. Now, you might be saying, well, I didn't have the same function over here. That's true, but it was in parentheses, so I was okay, because when I had the two equations, I had only cosine and only sine. But if you don't have any factoring going on, you'll need to do it this way. So I'm going to add sine squared to both sides, my little abbreviation, since I don't want to write the whole thing. So now I have 2 sine squareds equals 1. When I divide by 2, I get 1/2, and then I have to square root. Remember our little trick about square roots, you have to do plus or minus. So now it's the square root of 1/2, which, if you rationalize the denominator, will become radical 2 over 2. And that happens at 45 degrees. And since sine is positive or negative, it happens in all 4 quadrants. So these are, again, 180 apart, so I can say 45 plus 180n, or I can say, where's this one, 135 plus 180n. And those would be my answers. Another way someone might do this is, just real quick, and this is my little abbreviation again, if sine squared equals cosine squared, some people might actually divide by cosine squared, And then they might use their identities to realize that tangent is sine over cosine. So if this is sine squared divided by cosine squared is actually tangent squared then, and cosine squared divided by cosine squared is 1. So then you have tangent, when you square root both sides, equals plus or minus 1. And when does that happen? At 45 degrees, and it would be in all 4 quadrants. So you'd get the same answers. But I just wanted to show you there are other ways to do problems, especially when you get into the quadratic ones. So just because someone does it a little different, as long as you get the right answer and you've done it properly, you're good. So these are a little challenging, especially if you don't know this stuff. So you could do a screenshot, or you can look in your book and make your own little chart. Good luck with those. M squared, signing out.